Hello and welcome to Power Grid Expert, the YouTube channel about the electrical distribution grid. Today we will have a look at the intelligent secondary substation, and especially here in this part 2 we will have a look at the medium voltage switchgear. This is part 2 of the video series about the digital secondary substation. In part 1 we had a general overview. If you missed that video, I recommend you to have first a look at that one. The link you will find here. Part 2, the medium voltage switchgear. A few words about my person, Power Grid Expert. I'm offering consulting and services about the digital parts, the digital technology in our distribution grids. That can be protection relay planning, protection relay programming and testing. That can be trainings. That can be installation of measurement devices, of protection relays, or fault indicators. Let's have a look at the transformer station. Like transformer stations in every country look kind of similar, but never the same. Here we see an example from Germany, but basically it's pretty similar, I would say. And today, as I mentioned, we will have a look at the medium voltage switchgear, this one here. So we are talking about the blue marked area here. In the overview, we talked already about the transformer and about the low voltage side and the low voltage switchgear. We will have a closer look in those two later on, but today, as I mentioned, we will have a look at the medium voltage switchgear. The structure of each switchgear is pretty similar. In most cases, we have something like incoming feeder, outgoing feeder, and transformer feeder. If you now say, oh, wait, never heard about that, then have a look at that video, and there I explain the basic structures of our distribution grids. Welcome back. If you're now familiar with what's an incoming and outgoing feeder, we will see that in most transformer stations we have like 2 cable feeders and a transformer feeder, maybe 3 cable feeders, depending, up to 5, of course, but let's stick with what's most common here, and that's 2 cable feeders and a transformer feeder here with a switch and a fuse. So let's have a look at all that in an animation video. That animation video, you already know that transformer station from that substation from part 1. And today we will have an exclusive look at the medium voltage switchgear. And what we can see here is normally what you see if you open those doors. You see the front panel, you see the cable compartments closed as they should be. And now let's have a closer look. Let's start with where it all begins, at the incoming feeder. So what's going on here? As we clearly can see, this is a 3-phase system, hopefully, like it is always in medium voltage. So we have, for example, here the incoming feeder. This is the 3 plugs and the 3 cables coming out of the earth. Or from an overhead line, both is possible, of course, going into the switchgear. And this is the outgoing feeder, so the cable is going out from the switchgear here, going into the earth to the next substation. And we have the transformer feeder and the transformer feeder. Those cables here, they stay within the substation. They go to the medium voltage transformer. What we already can see, hey, there's a difference between those 2 cable feeders and the transformer feeder. Those plugs seem to be much smaller than those plugs here. What's that about? Very easy. Here in those 2 cable feeders, we have the whole ring supply current flowing not only what's needed in this substation, but also coming from the power station, going through the switchgear, going to the next switchgear, and so on and so on. So those cable feeders see much more current, much more power than the transformer feeders. So those are, in modern switchgears, normally are made to have a load current up to 630 amps. And the transformer feeder is only for 250 amps, which is way enough for most transformer sizes. So this is the reason why those plugs are, and also the bushings are much smaller. What we also can see, there's a difference between these two plugs here on the T part of the T-shaped plug, or the elbow plug, whatever you call them. There's a black cap, there's a silver cap, and those plug caps are normal plugs. These are plugs with integrated voltage sensors. We saw those sensors already in part 1 of the video, but there they have been built in at the transformer, at the meter voltage transformer. This position here, this installation location here, is another possibility to install those voltage sensors directly at the cable feeder of the switchgear. Another possibility is to integrate those sensors, voltage and current, directly in the bushing of the switchgear, and then we will not see them at all. So what's a bushing? A bushing is a frontier between the outside of the switchgear and the inside of the switchgear. So these little brown rings you can see here, they have a cone on top, and that plug of course fits on the cone, and that's it. And in those bushings are normally made out of cast resin. And in more modern switchgears, we have more and more sensor technology inside the bushings already. That's of course an advantage on the installation side, because you don't have to wire all these voltage and current sensors. The other idea about those integrated sensors is, okay, if ever I need to do something with those sensors, I need to change them or adapt them. If they're inside, built inside the bushing, they're inside, and it's not so easy to access them. So future will tell us what's the best solution here. And now let's go upwards and have a look at the front panel of the switchgear. And what we can see here is we have switches in all feeders. We have a load breaker switch that allows us to switch on and off the load current. We have a earthing switch. Out of the 5 safety rules, this is a must, so that whatever you do, you need to earth. If you do any maintenance with the cables, with the plugs, whatever. And let's assume this is the incoming feeder, as we already did. So we connect here to the bus bar. The bus bar goes on to the next cable feeder, outgoing cable feeder, next transformer station. Again, here is a load breaker. There's an earthing switch as well. And the bus bar continues to the transformer feeder. In the transformer feeder, we also have a load breaker. We also have an earthing switch, and additionally, this is actually behind this panel here, there is 3 high voltage fuses that switch off the transformer in case of any problem with it. That works fine up to an apparent power of roughly 1000 SVA. If it's a bigger transformer, normally we do not have a load breaker and fuses anymore. Then we have a power circuit breaker and a protection relay. If you ask yourself, what is a protection relay? Again, hint, there's a video explaining what a protection relay does. What we also can see is that there are different built-in devices, normally with a relation to the feeder, like those devices are connected to that feeder, those devices for that, and so on and so on. First, we see here 3 devices all showing 3 errors. Those are so-called voltage detection systems. They give an indication whether the switchgear is under voltage or not. So for maintenance, for switching, these devices are most important because, as you can see, this switchgear is there is no open part where you can check and with a zip or voltage detector, with mobile voltage detector, if there is voltage on the switchgear or not. So this is done with these integrated devices. Let's have a closer look at one of the cable feeders. We have, additionally to the voltage detection systems, we have built-in devices that are normally short circuit indicators. But nowadays in digital secondary substation, these devices not only check for faults, they also check for direction of the faults. They give and provide measurement values, load values, um, direction of the load, of course, the currents and the voltage, the powers, the cosinus phi, and so on. And they add some information to the operator of the network to know what's going on in his network. And if we switch over to the transformer feeder, we basically have the same. We have, depending on the philosophy of the grid operator, we have also here a fault indicator. Sometimes it's only built in to get the measurement values. Fault indication is not so important here in the transformer feeder. And what we also can see here, this is something new. This applies mainly to Europe, so far as I know, that within Europe, it's pretty sure and pretty clear that the isolation medium of the most common isolation medium in those medium voltage switchgear, which is SF6, will be prohibited in the following years. So all major switchgear manufacturers who are present in Europe by now have developed replacement technology to use instead of SF6, which is not so good for our climate and is not so easy to control in the whole life cycle of producing a switchgear, filling the switchgear with the gas, runtime, and at the end, the whole recycling of the switchgear. So there's different other technologies available. In this case, this is clean air. And in the load breakers, there is a vacuum switching tube to switch off the light arc during the switching. So if we have a look at the whole system, so what's the difference between a digital secondary substation switchgear, long words, and a classic switchgear? The classic switchgear, the main difference here is normally it does not have motors. So whatever you want to do, if you want to operate a switch here, you have to go into your car, you have to drive to the switchgear, and then you can switch. That's especially when you have a short circuit and a switch off and you need to isolate a part of the cable, which takes a tremendous amount of time. So in the digital substation, we normally have motorized switches that can be switched from the SCADA center remotely. And of course, in this case, you need an RTU, you need a UPS system, and those technologies I will explain in a later part of this video series. For now, if we talk about the switchgear, we need the motors here, the motor drives here, and also those devices here. In traditional switchgears, you mainly have maybe a short circuit indicator, and that's it. These modern devices deliver, as I told you, much more information, load values, measurement values, voltage and current, and so on, and provide the grid operator with much more information. And that information is used to see whether the grid is overloaded or not, gives him more information for network planning. So if there's an additional an additional DER asking to be connected to that ring, for example, the planner can have an easy look at the measurement values and tell the customer, yes, it's possible, or no, it's not possible. That's it with part 2 of the video series Digital Secondary Substations. Today we had a look at the medium voltage switchgear. If you like this video, please hit the like button, leave a comment, and or follow my YouTube channel Power Grid Expert if you're not already doing it. Thank you for watching. Thank you for the interest. If you have, as always, any questions or additional comments, feel free to hit me up. My contact data is below.